Okay, so I want to start this video with a simple experiment, all right? I want you to hold a pen up um, and close one eye. And this is actually better if you can get someone else to hold the pen for you. So I want you to close one eye and then move the pen sort of over to where that eye is, okay? Now, take your hand, this hand here, and move it out to the side and bring it in and try to touch the pen. So the key is bring your hand out of your range of vision where you can't see it. It's outside of your peripheral vision. And bring it in from the side and try to touch the pen with one eye closed. The key is doing it with one eye closed. It's a lot harder than you think. You would think it's pretty easy to touch a pen that's right here in front of your face. Now, if you open both eyes and you try to do the same thing, it's really hard to miss. It's extremely easy to know where the pen is. So we want to figure out why it's so easy to know where the pen is when we have both eyes open, but it's actually a bit difficult to figure out where the pen is when one of our eyes is closed. Okay, so hopefully the Harry Potter sounds in the background aren't too frightening. It's a big scary scene with Voldemort going on, but hopefully you're fine with that. So let's try to figure out why it is hard to see this pen. That's a rough representation of a pen. Hopefully you can use your imagination. Why is it hard to see it when we only have one eye? All right. So we can say, why would it be so hard for Nick Fury to touch the pen? So I'm going to represent the pen as a single point. All right. As basically we're looking at this as a top view. Okay. So here's Nick Fury. He has two eyes, but this one has been totally gone. All right. So if Nick Fury wants to see this pen, there has to be light coming in from somewhere. Now, light is actually, in most cases, not coming. Whoops, let me change that color. Let's make that yellow. Light rays are coming in from a lot of directions and hitting the pen. Didn't show up not because it was yellow, but because I was using the eraser. So light's coming in from a lot of different directions. Or maybe there's a window over here. There could be another window or a light bulb over here. Light could be coming in a lot of directions. And that light bounces off in all kinds of directions from the pen. But let me change to red. There's only one direction from the pen to Nick Fury's good eye, right? So in his brain, Nick Fury knows that the pen is somewhere on this line. He doesn't know where it is on that line, though. Now, our brain is good at guessing by looking at the size of the pen. We've seen enough pens to know about how large a pen is when it's, say, 1 foot away. So if a pen were 2 feet from us, we would see it was smaller, and we could probably make a reasonable guess about where it is. But it's hard to pinpoint it and actually touch it if we come in from the side. All right, so it was difficult coming in from the side and touching it with one line of sight, right? Now, if we started with our finger right in front of our eye and went directly out to it, I don't think that any of you would have trouble touching the pen. It's when you're coming in from the side, it's hard to gauge how far forward or backward it is. So it's easy to either slide your finger behind it or slide your finger in front of it when you're trying to touch it, especially if somebody else is holding it. It makes it more difficult. Right? Now, as soon as we have two eyes, it's very easy to locate where the pen is. So let me redraw the diagram. All right, we'll bring in Captain America this time. Maybe we'll be more gender inclusive. We'll bring in Captain Marvel here. All right, so light, which was coming, remember, from all directions, bounces off in all kinds of directions from the pen, but some of that gets to Captain Marvel's right eye. And some of that light goes to Captain Marvel's left eye. Captain Marvel has amazing powers. And one of those is that Captain Marvel will know where that pen is, right? But so did you, all right? It's pretty easy to do that calculation in your brain because you know that the pen is along this first line because of your right eye seeing it on that line. It has to be somewhere along that line of sight. And it also has to be somewhere along the second line of sight. I didn't draw that very well. Pen should be, let me just move the pen rather than change my lines. So the pen is right about there, all right? And we can pinpoint it really well if we have both eyes open. We can locate it without any difficulty at all, right? So humans actually are very good with fine motor skills, with things that are up close, because we can locate things by looking at the intersection of lines, right? So humans are very good at doing things like threading a needle. And these are things that are actually very important to developing technology. So being able to thread a needle is a really good thing if you want to build, very specific machines that will allow you to do something. Okay. You may have noticed that a horse is very bad at threading a needle, right? Okay, I know a horse doesn't have opposable thumbs. Okay, so that's a problem. But there's a reason with vision that a horse is actually very bad at threading a needle. So hooves are terrible for threading needles, but let's say that the pen is right here, all right? And you just use your imagination. Here's the horse's head. Oh, that's not terrible. I'll give it a little ears here. Okay, there's the ears. Looks a little bit more like a dog than a horse. But where does the horse have its eyes? The horse has its eyes out here and over here. Okay, so actually right now this horse probably couldn't see the pen at all. Okay, now if I had a pen, rather than turn the horse's head, which is how a horse can see things, it will turn its head from side to side. I'm just going to move the pen over to the left. Now the horse can see the pen with its left eye, but it can't see the pen at the same time with its right eye. So it has a hard time knowing exactly where the pen is, all right? Now a horse doesn't need to thread a needle. All it needs to be able to do is just stick its head on the ground and eat grass. So if it knows there's grass out there, it can do that. Now, there's a reason the horse may want to have its eyes out on the side of its head, and that's because if, say, over here somewhere, there's a big mountain lion, okay, there it is. It looks a little more like a sheep, okay? There's a lion, okay? Big fluffy mane, okay? Actually, mountain lions don't have manes. This is a lion. Somehow, some rich person had a lion and it got out of their yard. Okay, so the horse is looking around for predators. Okay, well, this horse can see this predator kind of out of the corner of its eye, way back there. All right, and it can see things way up here, so it kind of has a range of vision that's very wide. So it might see that lion trying to sneak up on it, and then a horse is very good at running away. All right. We might not see that lion because our eyes are in the front of our head. Okay, so we can't see out to the side very far, but we don't survive by running away from everything the way a horse does, right? In fact, if you look at animals in general, animals that are prey tend to have their eyes out on the side of their head, so they have good peripheral vision, whereas animals that are predators sometimes want to be able to judge distance better, so they may have both eyes in front of their head, but not all predators do. When you're looking at things far away, the two eyes don't really help all of that much. So let's imagine we're looking at a little house out here, which is a mile away. Well, if it's a mile away, our two eyes are basically, this is probably even exaggerating how close they are. So maybe this house isn't a mile away, maybe it's 100 meters away. The light coming from one point on the house is basically coming into both eyes at the same angle. Almost. There's a very tiny angle between those two rays of light coming from, say, the doorknob of the house. Okay. When that angle gets very small, it's very hard for your brain to compute a distance. Whereas in the example that we were looking at with the pen, this angle here is quite large, and so we can measure the distance pretty well. Similar things happen in astronomy. If we can measure the location, if we can get a line of sight on, say, a star or a planet from two different angles, we can locate it very well. So let's say we had observatories on both sides of the Earth. We might be able to, the difference in their viewing angles would be very useful for determining how far away the object is. But when things get further out in space, be more like this example here, the viewing angle between, observatories at both sides of the Earth would be so minutely different that we might not be able to tell the difference at all. So we have to have other ways of measuring distances when things get really far away. In general, the way we know how far away a house is when we're not standing near it is just by the general size of the house in our line of sight. If you're closer to the house, let's put somebody out here. A person here would see the house taking up in their viewing. It would take up a viewing angle from top to bottom, something like that, whereas somebody who's further out has a viewing angle that's much smaller, and so they see a lot of other stuff. They see more things around the house. As you get up close to the house, all you see is the house. If you're further away, you'll see the sky above it and the lawn in front of it, because it's not taking up as much of your viewing angle when you get further away. So we usually judge distances on objects that are probably more than about 10 feet away. We judge their distances based more upon their size than by seeing it with both eyes at once. So my father, for instance, was legally blind in one eye, but he could play tennis pretty well just by, how big a tennis ball is. You can, based on the size of the ball, you can tell how far away it is. By the time it's close enough that your stereoscopic vision is useful, the ball, it's too late to hit it, right? A similar thing happens if you have ever seen a 3D movie. If you want to see objects kind of popping out of the screen, you need two cameras at viewing angles that are fairly far apart as they look at an object, much like this. So 3D movies must be filmed with two cameras simultaneously, and the 3D effect only really comes into play for objects that are fairly close. Sometimes they'll put those cameras fairly far apart, so you get objects really popping off of the screen, often more so than in real life, which is a little disorienting. So I don't like to watch the movies in 3D because things are popping off at you more than they normally would. So I stick to my 2D experience. Plus, I like to save a few bucks.